Hi and good day to all students. So we move to the new subtopic 1.4 definite integrals. So at the end of this lesson, so students should be able to use the properties of definite integral. Okay, previously we have learned about indefinite integral, so now definite integral. So for the next thing, we are going to solve these definite integrals. Okay, and then part C. Okay, this is under application of integration, which is we are going to find the area of a region bounded by a curve and the x-axis or y-axis by the two curves, and also by a line and a curve. And for the next video, we are also going to learn on how to determine the volume of a solid of revolution bounded by the same thing as above. Okay, now we look at the properties of definite integral. For A, so we have lower limit A and the upper limit B. So C is a constant, so we just do a B minus A. For part B, we have two functions. We have two functions here, which is fx and gx. So we do the algebraic operations, okay, either addition or subtraction operation. So we just separate them up into fx plus minus gx. For C, okay, the same thing. We are taking out the constant c, and then we just leave the function here to be integrated. For part D, okay, we have the same limit for upper and lower, so we know that a minus a is a 0, so the integration will be equals to 0. E, okay, so if we look at these two limits, okay, here we have a to b, okay, from limit a to b, but on the right side here we have b to a. So the property saying that, okay, we just put negative over here, okay, then they are equals to each other. For the next is f. So now we look at a, lower limit, to the upper limit c. So now we have, okay, we could split them up into two functions, okay, so which is from a to b and then from b to c. Okay, the most important thing here, okay, you must see the lower limit. Okay, the beginning limit must be a and until up to limit c. Okay, and then the limit here, so must be the same limit. So please remember, if you want to split your limit, the limit here must be the same, okay, the blue one. And then you must see also the beginning and the ending point of the limit also must be equals to the original limit. Okay, and then the last one, okay, we have g. If the function is greater than or equals to 0, whereas, okay, b is greater than a and then c is greater than b, so mid of from a to b of that function also must be equals to 0, must be greater than equals to 0. Okay, so now example 12, given integration 2 to 5 of the function is a 5, and then 5 to 8 of the function is a 10, and then limits 2 to 5 of the function g is equals to 6. So evaluate each of the following. So now a, so we are doing a, so limit 2 to 5, 3 fx dx, so equals to, so in integration, okay, we should always take out the constants, okay, for easier operation. So now I am taking out the 3, so the limit left is a 2, 5 of the function dx. So as given in the question, so 2, 5 function dx is a 5. So the answer is 15. Next, b, okay, from lower limit 5 to 2. Okay, so this is quite confused. Okay, we know that the lower limit must be smaller than the upper limit. So now this question asking from 5 to 2. So now we are using the properties that we just learned from 5 to 2 of the gx dx. So we could change the properties 5 to integration of gx dx also equals to, so we are beginning, okay, we begin from 2 to 5 of the gx dx, but we must put the negative. So now negative, and then the integration to 5 of gx dx given in the question is a 6. So this is the answer. So now we look at part C. Okay, we have limit from 2 to 5 of the 2fx plus 3gx dx. So now we just break them up into 5 to fx dx plus, so another integration 2 to 5 3gx dx. So as usual, okay, take out the constant 2 to 5 plus 3 2 to 5 gx dx. So we take from the question given. So 2 of integration of 2 5 of the function dx is 5 plus 3. So from the question given, the integration 2 to 5 of the gx dx is 6. So 10 plus 18 is 28. And then for part D, okay, we have lower limit 2 to the upper limit. So clearly from the question, okay, we could see there is none about from lower limit 2 to 8. So what we must do is we are using the properties. Okay, the beginning point is from 2, the lower limit, and the upper limit is 8. We could extend the function into from 2 of the function dx plus, okay, the upper limit given in the question is 8 of the same function. Okay, so now we look at here. So the lower limit 2 and the upper limit 8, okay, the same as the question. So we look at the question, we are only have here, we have 2 to 5, 2 to 5, and then 5 to 8. Okay, so now we choose the same limit here, 5 and 5, because this is the only limit, okay, given in the question. So 2 to 5 fx dx is 5 plus 5 to 8 fx is 10. The answer is 15. Okay, now example 13, evaluate each of the following. So part A, so we're going to integrate the exponential function. So we have definite integral from the lower limit 0 to 2, okay, to integrate exponent to the power of 4x minus 2 with respect to x equals, okay, integrate exponent is we copy first, so exponent to the power of 4x minus 2 over, okay, divided by the derivative of the 4x minus 2 is a 4. So previously, okay, so we usually put plus c over here, but since this is a definite integral, so we put square bracket, okay, from lower limit 0 to the upper limit 2. Okay, so now we are going to substitute the upper limit 2 and also 0 into the solve integrate here. So exponent 4 2 minus 2 over 4, so subtract with exponent 4 0 minus 2 over 4. It's going to be exponent 8 minus 2 is a 6 over 4 minus exponent 0 minus 2 is a negative 2 over 4. So I could just simplify the solution, the answer, into exponent power of 6 over 4 minus 1 over 4 exponent squared. Okay, for next question, okay, for B, so now we have 2x power of 3 divided by the square root of 1 plus x power 4. Okay, so I believe that all of you have learned about the method of integration. So this function, okay, could not be integrated straightforward. So we must choose the correct method, which is substitution. Okay, because clearly from here, okay, I could see 1 plus x power of 4. When I differentiate, it becomes 4x to the power of 3. Okay, so let's get started. So here is a 0, 2, 1, 2 x power of 3 over square root 1 plus 4 dx. Okay, so now I use the method of substitution. So I'll choose u. So u equals to 1 plus power of 4. So when I differentiate, okay, it becomes 4x power of 3 dx. Okay, so look at to the original question. Okay, we have here 2x3 dx. Okay, here I have 4x power of 3 dx. So how to make it into 2x3 dx? Okay, so 2x3 dx equals to du over. Okay, so now we are going to substitute all of this thing into the question. So you would have equals to 0 to 1. Okay, 2x3 dx is a du over 2, is a du over 2. So here is a 1 over. So square root 1 plus x power 4 is a u. Okay, to make it easier to solve. Okay, so I'll put constant to the front, so it becomes 1 over 2, 0 to 1. Okay, so now to make it easier, okay, so we put the constant 1 over 2 to the front, so it becomes 1 over 2, so integration 0 to 1, 1 over u, so I just put here u, okay, to the power of negative 1 over 2, okay, for me to easy to integrate later, so du. Okay, so now we will integrate 1 over 2, so integration of u negative half is a u to the power of half. Okay, so u negative half plus 1 is a half over half, 1 over 2. Okay, so plus c. So plus c, we are going to use the upper and lower limit. First I put here c first. So because I want to integrate this, so cancel out these two. So now the answer is u to the power of half. Okay, so now I change back u. U is original in the function x is 1 plus x to the power of 4. Okay, to the power of 1 over 2. All of this, so which means the square root of 1 plus x to the power of 4. So limit from 0 to 1. Okay, square bracket. So now, okay, so we do a subtraction. So 1 plus 1 to the power of 4 square root, so minus 1 plus 0, okay, to the power of 4, which is 0. So please remember, okay, students, this method is a very important method, okay, which is substitution method. Important steps. Sorry, I mean this method. Okay, in the examination, okay, you must do this method. Okay, it's a must. So the last answer, the final answer is a set 2 minus 1. Alright. Okay, now we move to the application of integration. Okay, so what they can do. So in integration, okay, we can use to find the area and the volume of any function. So first here, okay, we look at to find the area between the curve and the x-axis. Okay, the most basic one. Okay, this is the curve and this is function. This is the axis. Okay, x-axis or y-axis. Okay, so first of all, we'll be looking at the curve, okay, between the curve of the function and the x-axis. Okay, so the horizontal one. So if f is continuous throughout, okay, from A to B, then the area of the region between the curve fx and the x-axis from A to B is given by A, okay, from the A to B, y dx. Okay, y here is actually your function fx. Okay, so simply I could change the formula here, A to B fx dx. So the function of x, okay, we are integrate with respect to x. Okay, if we look at the sketching over here on the left side, okay, we see the curve here is above the x-axis. Okay, so this curve, okay, which is the function, okay, so the area under this function, the area under this curve, okay, which is from A to B, okay, so we're gonna use this formula. Okay, so on the right side, okay, the sketching of the curve is below the x-axis, so the area would be negative, but we must put the modulus sign here, okay, which is, we know the area must be always positive. Area between the curve and the y-axis. So if S continues throughout, okay, from C to D, then the area of the region between the curve, okay, of the function y and the y-axis from C to D is given by, okay, A equals to integration from C to D x dy. So the same, x here is actually the function of y. So I put G here. So you could just simply, okay, you could change the formula from C to D gy dy to integrate function y with respect to y. Okay, these two sketchings below here, okay, so we could see on the left side here, okay, the curve is on the right of the y-axis. So the area under this curve, so we refer to the y-axis. Alright, so the area under this curve, so which is A from C to D, so we're going to use this formula. Okay, so the same goes, okay, when we look at the sketching on the right side, so it is actually on the left side of the y-axis. So y-axis has the reference line here, so the area under this function, okay, so we'll get negative, then we put modulus here because the area is always positive. Example 14, sketch the graph of y equals to x multiplied by x minus 2 from the domain negative 2 to 4. So this graph, okay, we could see the function is a quadratic function because when I expand, okay, become x squared minus 2x, so positive quadratic. Okay, and then the root here, so I know the x-intercept, okay, is going to be 0 and 2. Okay, so I just simply sketch from negative 2 to 4. So negative 1, negative 2, 1, 2, 3, 4. Negative 2 is 0, 2, 4. This is y-axis and the x-axis. Okay, so we know that this graph would be, looks like smile, and then the roots is at x equals to 0 and x equals to 2, which is the x-interception, 0 and 2. Okay, what else? Okay, so you could plot, okay, if you are not sure about what will be the graph looks like. So from negative 2, when x equals to negative 2, so negative 2, negative 2 minus 2, negative 2 is 8. Okay, so negative 2 and x equals to negative 2, so about there. And then when x equals to 4, 4 minus 2, 4, 2, also 8. Okay, so somewhere here. Okay, so the minimum point, so I could just simply sketch the graph. So this will be your graph, okay, will be looks like it's smiling, okay, positive quadratic. Okay, sketch the graph. So I have sketched, then it's done. So next question, what is the area B? Here we look at B. What is the area between the curve, between this curve and the x-axis, bounded by x equals to negative 2 and x equals to 2. Okay, we must first put the limit line first. Okay, change back to the blue one. Okay, here is 2. So from negative 2 to 2. So from here to here. Okay, so the question asking to find the area between the curve and the x-axis. So the curve and the x-axis. So we look from the negative 2 to 0. So the curve here, okay, the green one. Here the x-axis. So this is the area under the curve, okay, and then from 0 to 2, okay, so between curve and line, so between curve and line, so the red one, so the lorette is there, so we could see clearly, okay, this is the question asking about to find the area between curve and x-axis, okay, so the area is A. Okay, so since we look at the region bounded here, okay, first part from negative 2 to 0 is a positive area because it is above the x-axis, okay, while from 0 to 2, okay, it is below the x-axis, so the area would be negative, so we just put modulus later. So slowly we begin from negative 2 to 0 of the function dx, this is the formula, and then we plus, okay, we add up with the next domain 0 to 2, okay, of the same function, because here only one function involved. So now we put the function negative 2 to 0, so the function is x minus 2 dx plus, so we put modulus here, okay, as I said, okay, it will be negative, so because it is below the x-axis, so the function is x minus 2 dx, okay, equals to, okay, I haven't yet integrate them because it is easier if I expand this first, x squared minus 2x of respect to the x plus from 0 to 2 x squared minus 2x dx. Okay, so now we integrate them, so x to the power of 3 over 3 minus 2x squared over 2, so from negative 2 to 0, square bracket, plus, so the same here, x power of 3 over 3 minus 2x squared divided by 2 from 0 to 2, okay, equals to, so it will be straight away, okay, to the soft one, which is 20 over 3, okay, for the left part here, plus, okay, so the modulus one, okay, so you'll be getting here negative 4 over 3, so you try out, guys, so make sure you try out them. So the answer, the final answer will be 8, since this is area, so 8 unit squared. Now we look at the example 15. Find the area of the region bounded by the curve y equals to x cubed. Okay, x to the power of 3 plus 3. The y-axis, the lines y equals to 2 and y equals to 4. So now we have cubic function. So do you still remember how the graph will be looks like? Okay, for the cubic function. So to find the area of this region, okay, you must first try to sketch the graph. Okay, if you don't, then you couldn't see, okay, where will be your beginning limit and the ending limit, okay, to find your area. Now we try to sketch the graph, okay, even though they did ask to sketch the graph. So the cubic function, so plus 3, so the y-interception here is a 3 when x equals to 0, y equals to 3. So here is a y-axis, so I scale, here is a 1, 2, 3, 4. 1, 2, 3, 4. Okay, the lines y equals to 2 and y equals to 4. So I use a different color. So here is a y equals to 2, and then for y equals to 4, so I choose orange. Here is y equals to 4. Alright, so the graph x squared plus 3. So the graph is the red color. So the positive cubic function and the positive. Okay, so we started from here. Okay, so the intersection here and here. So we could just substitute into the function. Okay, to know the intersection here between line and curve, okay, we just substitute y equals to 2 here. So y equals to 2, 2 equals to x cubed plus 3, x cubed, x power of 3 equals to negative 1. So x equals to negative 1. Here is a negative 1. So while at the point here, so intersection when y equals to 4, so 4 equals to x cubed plus 3, 4 minus 3 is 1. So x equals to 1. So we have done. Okay, sketch our graph. Y equals to x cubed plus 3. So what will be the region? Okay, look back to the question. Find the area of the region. Find the area of the region bounded by the curve, the y-axis, lines y equals to 2 and y equals to 4. So there are 4 bounded line here. Okay, we have curve, we have y-axis, and 2 lines, which are y equals to 2 and y equals to 4. Okay, so I want to change the original color of which will represent of every line here. So y equals to 4 is orange color. So y equals to 4, oh, is an orange. Y equals to 4 is an orange. And then the red one is a curve. So curve is the red one. Y-axis is the blue one. Y-axis, okay, blue color. Okay, and then the other one, the y equals to 2 is purple. Okay, so we have purple, blue, red, and orange. Okay, so we gotta find out, okay, where would be the region located. So, okay, so as we look at the y-axis as a reference, so this would be the region under the curve. So y, okay, we see here, okay, there is a red color, orange color, and blue color. So this is the curve, the red one, orange, y equals to 4 line, and then the blue one is the axis, the y-axis. And then the shaded here also, okay, we see the bounded region, the region is bounded by y equals to 2 line, the axis, the blue color, and the red one is the curve. So these two are the regions bounded by the curve and the y-axis. Okay, if you want to get clear of this, okay, to get clearer info, so you see your tutorial lecturer, okay, and discuss with them. Okay, so now straight away, okay, want to find out the area. So the area A equals to, so the limit is from 2 to 4, but there are 2 regions here, so we choose the lower limit. The lowest is from 2 up to 3, okay, of the function. So function, oh, alright, so we haven't yet changed the function. The function here is y equals to x power of 3 plus 3. Why must we change the function? Because here I want to find the area, okay, and then I want to integrate with respect to the y, which is on the y-axis. So I must change the function x into the function y. So x power of 3 equals to y minus 3. So x equals to y minus 3, the cubic root, so I change to index form. Okay, easier to integrate, so 1 over 3. So this is now, okay, I've changed the function into the y, into the function of y. So here is y minus 3, with respect to y. Okay, that is why we have to change the function into the y function. Okay, we have another region from 3 to 4. Okay, also the same function, which is y function now, function y. So y minus 3 to the power of 1 over 3 dy. Okay, straight away. Okay, we're gonna integrate this function. So y minus 3 1 over 3. So it becomes y minus 3. So 1 over 3 plus 1 is 4 over 3. 4 over 3 divided by 4 over 3. And then this is a linear ax plus b. So derivative, not derivative, we take the a is 1. And then the limit from 2 to 3 plus, okay, so here also, okay, we're getting the same integration, 3y over minus 3. Here is a 4 from 3 to 4, so equals to 3 over 4 plus 3 over 4. Okay, the final answer is, okay, will be 3 over 2 units squared. On this side, okay, if you try yourself, okay, you'll be getting this in negative. Okay, you must put modulus because since the region is on the left side of the y-axis. Okay, so I put modulus here. So the actual answer here is a negative 3 over 4. So when I put modulus, it becomes positive. So 3 plus 4 plus 3 plus 4, which results to 3 over 2 units squared. Can I ask you, can I find the area with respect to the x-axis from negative 1 to 1? From negative 1 to 1. Can I find the area from negative 1 to 1 with respect to x? Which means I will stay using the function x. Can you? Okay, so you may ask this question to your tutorial lecturer. Okay, now we move to the when the area bounded by the two curves or a line and a curve. So now we look at these two sketching. Alright, so these two sketching got two functions, which is y equals to fx and y equals to gx. So for this case, how are we going to find the area? We will subtracting the upper function, which is fx, minus the lower function, which is gx. So this would be the formula when we have two curves or two functions. We have limit from a to b. So we have limit from a to b, and the upper functions is fx, or we could have another color in order to identify which function is larger than the other function. So when I draw a line here, okay, so we could see this function and this function, the fx is above the gx. So now fx is the upper function, gx is the lower function. So the upper function will subtract the lower function, fx minus gx. So for the right side sketching, okay, we do have also two curves. Okay, this is first function and second function. So for this case, we gotta look the function at the most right, and then which function that will be to the left side. So when I do a line of horizontal here, so fy is at the most right and gy at the most left. So in this case, fy is the right function, and while gy is the left function. So the same thing, limit we are taking from c to d. Okay, the integration of c to d, then fy minus gy, the most right function, subtract the left one. Okay, because we are referring to the y axis. So I think all of you have the idea on how to solve the area within the two curves. Okay, so again on the left side here, so we are taking the most upper minus the lower function because we are referring to the x-axis, while on this side, okay, we are referring to the y-axis, then we are taking the most right subtract to the left function. Okay, so these are the two formulas that we are going to use after this when we have two functions or two curves. Okay guys, this is the paragraph, okay, which explain the similar things that I just explained to you. Upper function minus lower function for x-axis, okay, we could see from ds here, and this one is the formula for two curves or two function, which is right minus the left function for when we are referring to the y-axis. Example 16. Calculate the area of the region bounded by the curve y equals to x squared plus 3 quadratic, the linear function 3y equals to negative 2x plus 14 and y equals to 3. So first, I think let's we represent this function as y1, this one as y2, okay, the last is y3. So to find the area of the region bounded, okay, so by these three functions, okay, we have quadratic and two linears. So first of all, as usual, it is better for us to have the sketching first, because from there we will see and identify which the regions to be bounded. Okay, just a very simple sketching here. So we have y(x squared plus 3), so this is a smiling graph which will cross the 3 here, okay, y-intercept. y2 is a negative, okay, so negative gradient. Okay, so let's sketch. So we know the first quadratic will intersect at 3, so just a simple sketching here. So the most basic one, oops, okay, we're gonna use the different color. So first, okay, take the blue one, okay, something like that. Okay, next, okay, this graph is will have a negative gradient, and then the y-intercept, use the purple color. So y equals to negative 2 over 3x plus 14 over 3. So we know the intercept will be at 14 over 3. That is about 4.7 something. Let's say here is 5. Okay, just a simple sketching. Okay, the last one is a y equals to 3. So y equals to 3. Okay, take orange. Y equals to 3. So this is y equals to 3. This one is 3y equals to negative 2x plus 14. While this one is a quadratic, y equals to x squared plus 3. So now, where would be the area of the region located? Okay, so try to guess. Is it here? I think here, because it looks nice to be there. Is it correct? Oh, is it here? Okay, so if you see here guys, I have drawn, I have sketched this sketching by using 3 colors, so that you could see the difference between the curves, between the line. Okay, and then the question tells us this region must be bounded by the 3 curves, the 3 function. So it must be bounded by the blue color, okay, which present this function, and then this region also must be bounded by purple color, and also this region also must be bounded by the orange color, by these 3 colors. So if you look at the first here, if you think the region is here, you see on the left side they are open to the left side. So this one is not be bounded by any curves because it is open to the left. How about here? So now bounded by the purple color, purple line, bounded by the blue color, but it is not bounded by the orange color. Okay, and then what you do if we look at the last region here? Okay, this region it has been bounded by the blue color, the purple color, and the orange color. Okay class, this is the region that we are going to find the area, because the three colors which represents every function here, y1, y2 and y3. Here is y1, here is y2 and here is y3. So now firstly we have to find the limits in order to find the area, because when we have limit then we have can find. Okay, referring to the x-axis, so we could see the limits here. So here, here and of course here. So we have to find the intersections points at this point, at this point and at this point. Okay, first intersection points between this y1 and y2. So how to find intersection points? So what we do is, okay, we equate two of them. y1 equals to y2. It's just like what you learned in your school. To find the intersection points, okay, we are going to equate these two functions. y1 equals to 1, 2. So y1 is x squared plus 3, while y2 is negative 2 over 3x plus 14 over 3. So now we are going to solve them. 3x squared plus 9 equals to negative 2x plus 14. That will result to the quadratic equation, which is 3x squared plus 2x minus 5 equals to 0. And then this quadratic could be factorized. Yes, it can be factorized into 3x plus 5x minus 1 equals to 0. So from here we know that the x equals to negative 5 over 3 and also x equals to 1. Okay, so the intersection points here is 1. So negative 5 over 3 is actually somewhere here, negative 5 over 3, but we won't use this point as the region is not here. Okay, so okay, we have to find another one point, which is here. Here is a 0. We know that there is a 0 there, so here is 1. And then this part. Okay, for this part, use the orange color to find this intersection point. Okay, we're gonna equate the y equals to 3 with the purple and the orange. The purple, so y2 equals to y3. Okay, so y2 equals to y3. So y2 is negative 2x over 3 plus 14 over 3. y3 is a 3. So negative 2x plus 14 equals to 3 is 9. So x equals to 5 over 2, 2.5. So here is a 5 over 2. So now let's begin to find the area. Okay, let's restart. So this is the sketching that we have is now. So we're going to find the area. Okay, when we look at this region, okay, I have to split them up into two parts. Okay, which is, here is a part A and here is a part B. So why should I split this up into two parts? Because every single parts here, there are limited functions involved. For example here, okay, if we look closely to the part A, only two curves involved here, which is the blue one and the orange one. On the next side, okay, when we look at the part B, also the curve involved here is only the orange one and the purple one. So the area, so I am taking from beginning point from 0 to 1. So for part A, so which one is the upper function and the lower function? So of course the blue one is the upper function. So y1 is x squared plus 3. Okay, we will subtract the lower function, which is the orange one, which is y3, 3. Okay, so with respect to x, plus, okay, you want to add up with the second part of B, which begin from point 1 to 5 over 2. So for part B, okay, look closely. Okay, there are only two curves involved here, the purple and the orange. So the purple is the upper function, okay, while the orange is the lower one. So the purple minus the orange, purple is a y2, negative 2 over 3x plus 14 over 3. Okay, we'll subtract 3. So let's rewrite back. Here is a purple, which is y1 minus y3, upper minus lower function. Okay, on this side, the part B, this one is a y2 minus y3. Okay, this step is the most essential part to find the area. If you got them wrong, then everything after this will be wrong. So make sure they are correct. Okay, upper minus lower, upper minus lower. Okay, if we are referring to the x-axis. Next, so I'm going to simplify the function first before I integrate. So 0 to 1, so x squared plus 3 minus 3, 0. So dx plus from 1 to 5 over 2, negative 2 over 3, 14 over 3 minus 3 is 5 over 3 dx. So now the function has been simplified. Then we integrate. So x to the power of 3 divided by 3, square bracket lower from 0 to 1, plus square bracket, oh, you got negative 2 over 3x. Then when we integrate, we're getting x squared divided by 3 plus 5 over 3, starting from 1 to 5 over 2, equals 1 over 3 plus 3 over 4. And your final answer is 13 over 12 unit squared. Alright guys. Next page, example 17. Find the area of the region bounded by the curves y equals to x squared minus 5x and y equals to 25 minus x squared. Okay, there are two functions here. There are two curves. One is a positive quadratic, while the other one is a negative quadratic, 25 minus x squared. Okay, as usual. Okay, we're going to sketch them first in order to describe how the region will be looks like. Okay, to sketch, so this is a positive quadratic function, x squared minus 5x, so x minus 5. So the roots is x equals to 0, x equals to 5. While on the other side here is a negative quadratic that will intersect at 25. So it's very simple. This one the root at 0 and 5. So let's start to sketch. So just a simple sketch. So 0 and 5, so let's say it's around here, 0 to 5, 0 to 5. So how about this root here and here? So the roots is negative 25 minus x, 5 plus x, so 5 minus x, so x equals to plus minus 5. Okay, so I'm going to sketch the y2 first, 25, and the y1, which is the positive quadratic, okay, is x squared minus 5x. So we are taking the yellow one. So the graph is smiling, which will hit 0 and 5. Okay, something like this lah. Okay, so now the region. So the region bounded by these two curves must be bounded by these two colors, which is red and yellow. So we could see obviously the region is here, bounded by the two colors, yellow and red. Before we could find the area, we must first find the intersection point. Okay, here is 5. Okay, alright. Here is 0. Okay, but how about this? Okay, at that point, the intersection points is between y1 and y2. So as usual, we would equate these two equations. So y1 equals to y2, so x squared minus 5x equals to 25 minus x squared. So result to a quadratic equation, 2x squared minus 5x minus 25 equals to 0. So it can be factorized into 2x plus 5 and x minus. So now our x is negative 5 over 2, and also x equals to 5. So x equals to 5 is already here. So this point here is a negative 5 over. So now I am referring to the x-axis to find the area. So when we look at the x-axis, so which function is the upper function and which function is the lower? So if you can't see, let's draw the vertical line Okay, I just draw the vertical line here. So we could see the red one is the upper function, while the yellow one is the lower function. So now let's get started to find the area. So area equals to, okay, the integration from where to where? From negative 5 over 2 to 5. Okay, so which one is the upper function? The red one. The red one is x squared, sorry, 25 minus x squared. So 25 minus x squared minus x squared minus 5x with respect to, okay, there is no need to split, okay, to split this region into 2 parts or 3 parts, because if we see closely, okay, look closely to the function, to the region here, from negative 5 over 2 to 5. If you look from negative 5 over 2 to 5, obviously only 2 curves involved. There is no other curve, so straight away we could just substitute into the formula of area between 2 curves, which is y2 minus y1. Okay, we simplify with the function first before we integrate. Okay, we have here 25 minus is a minus 2x squared plus 5x, all of this with respect to x. Okay, so now we integrate. So we're getting 25x minus 2x cubed 3 plus, okay, so the lower will be begin from negative 5 over 2 up to 5. So we're going to substitute the upper limit first. 2 over 2. Okay, this step must be done. Okay, then just simply use your calculator, okay, to find the final answer. This step must be done. Okay, must be written clearly. 25 negative 5 over 2 plus, so minus 2 negative 5 over 2 3 over 3 plus 5 negative 5 over 2 3 over 3. Okay, K1 for this step, and then the final answer is 140 5 over 8 units squared.